All right, welcome back. This is lecture 2B. So we want to talk about doing input and output on the PIC processor. And if we come back to our data sheet, and remember we're using the 18-pin version, so it's this picture up here that's relevant. We mentioned that these pins have multiple functions, right? Pin 1 has the possibility of acting as what's called RA1. Pin 2 can be RA0. Pin 2 can be RA1. Pin 6 can be RA2. Pin 7 RA3, and so on. There's an RA4, there's RA6 and RA7, and there's RA5. What are these RAs? They are digital input and output ports. They're ways that we can read and write ones and zeros, right? Either into this chip or out of this chip. So for example, if we hook a switch up to RA0 and we wire that switch correctly as in 250 so that we can put in either 0 volts or 5 volts, we would like to be able to somehow in a program know whether this pin is set to 0 volts or 5 volts. Or maybe we want to hook an LED up to this pin here, which is RA7, and in our program we want to somehow say, I want to put 5 volts on this pin so that the LED turns on. Or I want to put 0 volts on this pin so the LED turns off. So we want the option of being able to input to this chip or output from this chip. And the way we do that is by using these special function registers. So we mentioned these briefly in the first week. These are additional locations in our data memory. They all have an upper 4 bits of F. Okay, so we have to use the access bit properly to get to these locations. And we're going to talk about a few of these today. We're going to talk about port A and latch A and tri-state A, as well as a couple of others, namely ADCON 1. And then port B, latch B, and tri-state B will work the same as the A counterparts. So let's look at this. Let's see what latch A is. So latch A has an address of F89. So F89 hex. That's latch A. Okay, let me give you an example. Suppose we say move literal into W1. So wreg equals this binary mask. And then we say move W register to file register hex F89. Well, since F89 is latch A, here's what's going to happen. The value of this bit is going to be sent to the pin labeled RA0. The value of bit 1 is going to go to the pin labeled RA1, and so on. This goes to RA2, RA3, RA4, and so on. So if we have an LED on pin 1, which is RA0, and we execute these two instructions, that LED will turn on. Because we'll be saying, let's send a logic 1, which is 5 volts, to RA0, and that comes out on pin 1. On the other hand, if we had an LED on pin 2, that LED would now be off, because we sent a 0 to RA1, which is 0 volts. But now if we say move LW2 and move WF F89, well, that's what the number 2 looks like in binary. So we're sending a 0 to RA0, so that LED would be off. But we're sending a 1 to RA1, which is on pin 2, that LED would be on. So the 8 bits that we send to this file register are sent one by one to each of these RA outputs, RA0, RA1, R2, RA3, and so on. Okay, that's the basic setup for doing output on the PIC processor. And to do input, we read from this port called port A, which is hex F80. So suppose we do the following. Move file register F80, 0. And my comment here is port A is being sent into the W register. Well, after this instruction executes, the W register is 8 bits. Well, if externally I had connected this pin to 5 volts, and then I said move port A into 0, this bit here would be a 1. And if I have pin 2 RA1 connected to 0 volts, and I execute this instruction, this bit will be a 0. So by doing this one instruction, by copying hex F80 into the W register, my W register contains 8 pieces of information telling me what the voltage level is being applied to these 8 pins that are labeled RA0 through RA7. So with a single move instruction, I can read the values on those 8 pins. All right, that's the basic setup, okay? And that's what you want to think of when you're trying to do input and output operations with the PIC processor. But of course, there's some details. So one detail is, remember, RA0 has multiple possible functions. Could also be something called AN0. RA1 has 3 possible functions. RB6, which is port B's bit 6, has 6 possible functions, right? So how does the system know what we want to do with these pins? So we have to do 2 things before we can use latch A and port A. The first one is the following. Move 7F into W, and then move WF into something called ADCON1, which is location FC1. So ADCON1 gets set to 7F. That's just something we're going to have to do for the next few weeks anytime we want to use these RA or RB pins. The other thing we have to do, though, depends on what exactly we want to do. We have to tell the PIC processor, are we trying to do input or output on these pins? If we're trying to do input, then we don't want the PIC processor to apply a voltage here. If we're hooking this pin up to ground to input a 0, we don't want the PIC processor writing 5 volts to that pin. Okay, that's going to cause a short. On the other hand, if we're trying to read from if we're trying to send a value out this pin, right, the PIC processor has to know that it's safe to do that. It has to know that this pin is not connected to ground or 5 volts externally. So we have to tell the PIC processor what we want to do with each of these 8 bits, RA0, RA1, and so on. And the way that we do that is by using a register called Tri-State A, TRISA. And TRISA is F92. And here's how this works. Suppose we say move literal into W 0. And then we move WF into F92. So here's what TRISA looks like. It's got 8 bits, and we've written zeros into all 8 of those bits. Well, each of these positions corresponds to, again, RA0, RA1, RA2, and so on. But depending on whether we write a 0 or a 1, we're telling the PIC processor we want to use this pin for output or input. Okay, so here's how we interpret these. If we write a 0, we're saying, hey, we want to do output on this pin. If we write 1, we're saying we want to do input. So by writing zeros into here, I'm saying I want to use all 8 pins for output. But if I had written something like this, a 1 here and a 1 here, I'm saying I want to use RA2 and RA3 for input and all these other pins for output. Right? So each bit that I put into tri-state corresponds to one of these pins, and a 0 says let's do output, a 1 says let's do input. And the mnemonic I use for remembering that, right? Think of this as an O for output, think of this as an I for input. Okay, so output, input, that works. So we can set up each of these pins however we want. So if we want to do I/O on a pin, we have to do 3 things. 1, we have to set up ADCON1 to 7F. That's just standard, we're always going to do that. 2, we have to set the tri-state A register and put in 1s for any position we want to use for input and 0s for any position we want to use for output. And if we're not going to use the pin, it doesn't really matter what we put there. And then 3, we have to go ahead and we have to actually read from latch A or write to latch A. And if we read from latch A, the value that we read into W register, for example, will correspond to the input values that were coming in on the pins. If we write to read from port A, if we write to latch A, the values that we write will appear as voltages on the corresponding pins. So that's our basic setup for doing input and output. And there'll be some homework to practice on that as well. And this will be the main thing that we're doing in Lab 2. All right, so we're going to have one more video this week for the first class. I want to talk about what are called assembler directives, and that's a pretty quick concept, but I want to get through that before the next class. So we'll have one more video coming up.